So one thing that you need to keep in mind is that you can actually overflow your numbers if you have something that is too big. So a good way of showing this is if we create an int x and then we say we want int max value, right? So this is actually the highest representation that an int can be. So what happens when we do this? When we add one more to the highest thing an int can be? I believe that we will get a runtime error, which means difference between a compile time and runtime error. Compile time error is when you're actually building up the program, and usually that's what the IDE, in this case Visual Studio, catches, and that's the red squiggly lines. A runtime error is an error that occurs while your program is actually running, and it's very bad. These you don't get squiggly lines on. You don't really know until you run the program. So let's run this program, and it actually exited fine. So that's not a problem. There's this way of checking to make sure ints don't overflow. Because technically this int is overflowing, it's going into a piece of memory where it shouldn't be, and that's just bad. This is how security vulnerabilities happen, and just ways that hackers can get into places that they definitely should not be in. So in order to stop this sort of thing from happening, you can actually type in checked. And checked is not written like this. My bad. Checked is written like this. And what checked does is it makes sure that you are not overflowing or underflowing your ints and numeric types. So let's go ahead and try running this again and see what happens. Boom. Alright. So Visual Studio is showing us that we got an error in the system.overflow exception. So the arithmetic operation results in overflow, and that's exactly what we knew was happening. So this is the good thing about the checked, and to make sure that you do not overflow or underflow your numeric types, and it's just very important and good coding practice. And with all that said, there will be times where you do not want something to be checked, so you can type in unchecked as well. And if we run this, it'll run fine. It'll go through, not knowing that you're messing it up. So there are always cases where you're going to need to break the rules and stuff, but it's just good convention to do that as low as possible and to always know where you're doing that. And it has to have a very good purpose, because that's a potential security vulnerability. Really quickly, the 8-bit integral types like short byte, sbyte, and ushort. Ushort stands for unsigned short, and then I'm not sure what sbyte stands for, but if you use a short value and then just say that is equal to 1, and then a short, well, actually just do this on the same line, equals 1 as well, and we want to create a new short, this will not work. Shorts, all these types that I mentioned just previously, do not support addition, because what this does is it converts it into an int. So what we could do is cast this back into a short before we turn it back in. We have to add parentheses all around this, but we can actually use this short conversion. What's happening here is when we add these two, it's converting it into an int, and short is too small of a data type to actually take that. So floats and doubles actually have a couple of special values that I'm just going to show really quick, just so you're aware of them. Some of these are not a number. Another one is positive infinity. Another one is negative infinity. And you can actually create a -0 with doubles or floats. And basically these are the exact same thing with floats. You just change out double for float, and then you add an F here if you want to float -0. But yeah, I'll print those out with a read key really quickly so we can just see what those look like. So they actually have an infinity symbol that they print out. But yeah, that's the special float and double values. And you can actually divide double values by 0, and it'll actually work. So what will happen is it'll give you infinity. So for this one, it's positive infinity. If you had negatives on the 1.0 or the 0, just 1 though, it would be negative. But if you had negatives on both, then obviously it'd be positive because those negatives counter themselves out. And that is it for numeric types.